Okay, so for the next question, we have a little bit of a word problem, but they give us the equation. So it says Oregon's population can be approximated by the equation y equals 0.027x. And by the way, this is 27 thousandths, because it's 3 decimal places with a th on the end, plus 3 and 819 thousandths, or 3.819, where x represents the number of years since 2009 and the population in millions. Okay, so y is actually the population in millions. And that's why we're using decimals here, because otherwise, if I'm saying this is in millions, that means that's actually 3,819,000, right? So in millions means you would multiply those numbers by millions. How much is the population based on this equation? Can you tell where does what was the population of Oregon in the year 2009? Well, that would basically be where we're starting out. So if I have x is 0, that corresponds to the year 2009. And then what would the population be? If you plug in x is 0, what's left? $3.819, correct? Now, how much is the population increasing every year? If we're saying that this number is in millions, if we took 0.027 and we multiplied it by a million, does anybody know how many zeros a million has? It has 6 zeros. So that's moving the decimal over 6 places. That means my population in Oregon is increasing 27,000 every year, right? If we want to complete the table, of course I could plug in 1, I could plug in 2, I could plug in 3, but since we just learned how to use the table of values, why don't I just go ahead and plug that into the table? It already has y equals. So I go back to my table I create my table by going back to my y equals. What do I want to do first when I go to y equals? I don't want to be confused by this other equation. That was another equation for another problem. So what should I do with it? Yeah, I can just clear it out. I can scroll down to it and I can press clear. Okay, so to type in this equation, 0.027 times x plus 3.819. And earlier on today, I was having a conversation with some math teachers. We were saying, yeah, you should probably put the 0 in front. Your calculator will understand if there's no 0 in front of the decimal, but it's, not that hard to put it in there. I just didn't put it in. Okay. Now, if I want to get this table of values, I go, what do I do to get to the table? Second graph. Now, my table is already set up to count by tens, and look at this, I need to count by ones, so I need to change it back. So I go second table set, right here, table set, I want to start at 0. How do I want my table to change? By 1, so I can override the 10 just by typing in a 1. Now I go second table, and look, it's counting by ones now. Okay, so this allows me to get my new numbers. So for after 1 year, my population is 3.846. After 2 years, 3.873. And after 3 years, 3.9. Okay, of course you could be just adding on the increase every time. For every value of x going up by 1, we're going to add 27 thousandths to the next number. And now this comes down to interpreting what is the meaning of these points. So remember I was saying anytime you have x, you have your y value. We call this the starting point or the y-intercept. And we'll know more about why that's called that when we get to graphing pretty soon in the upcoming lessons. But in the context of the story problem, interpret the ordered pair. So we know this is the y-intercept, but what does it actually mean? So if we said x is year 0, that's 2019. Where am I getting that? Because they're saying x represents the years since 2009. 2009. Did I say 19? I meant 9. Okay, so in 2009, the population of Oregon, is the population just 3 people? 3.819? No. It says the population in millions. So if I come back to that idea of, and by the way, to get out of that table, if you're in the table, you can go second, quit, and that's going to take you back to your regular menu to do math with. So if we take 3.819 and we multiply it by a million, which is 10 to the 6th power, or 1 followed by 6 zeros, and now I lost count. Is that 6 zeros? Looks like it. We get 3,819,000. So that's where the population is starting out in 2009. We want to use the equation to estimate the population in 2013. So what would I do to estimate the population in 2013? What should x be equal to then? And how did you get 4? Exactly. If you take 2013 and you subtract 2009, you get 4. So that means x is equal to 4. And if we plug that in, we get y equals 0.027 times 4 plus 3,000 or 3.819. And again, I can go back to my table and I can scroll down and I see that I get 3.927. So what does that mean? If we want to interpret our answer in a complete sentence, what does that mean that the population is in 2013? In 2013, the population is, any thoughts? Yes, 3,927,000. I could put in Oregon. I don't know why I put in parentheses. Okay, use the equation to estimate to the nearest year when Oregon's population will be over 4 million. Interpret your results in a complete sentence. So over 4 million. What should I do to figure this out? I could look at the table, sure. But if I did want to solve it algebraically, I could say, since y is the population and x is the year, if I set up 4 is equal to, or you could even use an inequality, 0.027x plus 3.819, you could solve for x. Okay, I have a lot of decimaling numbers, and of course I could use my calculator for that, but I like the idea of using the table. So essentially, I see it's going over 4, and this is in millions, after 7 years. So what year will it be when the population is over 4 million? And how'd you get 2015? X equals 7, so we have 2009 plus 7 years gives us 2016. So in 2016, the population is over 4 million. The tricky thing about these problems is that you're converting your x's into numbers and then back into years, or from years into numbers. And the other tricky thing is you're having to convert numbers that are in millions back into millions, right? Or to actual, like if they say over 4 million, you're not going to put 4 million into the problem. So that's what you have to be careful of. And then, of course, you could also do the algebra, subtract your 3.819 and divide in order to solve that. You could actually use your calculator for that too. If I quit my table, I'll just quickly show what that would look like. So if I go 4 minus 3.8, oops, that's not 8, 819 is this. And then if I divide by my coefficient, I have 0.0827. And you can see that that's, if we round it off, it's getting close to 7. Of course, on the table, you couldn't see that exact. That would be when the population is exactly 4 million, right? But then to translate that into years, it's practically 7 years, okay? Any questions about this before you continue with your activity? One variable, okay, let